Hello, everybody. Thank you for sticking around this afternoon. It's good to see the crowds that I've seen here today. Just a quick introduction. Well, first thing I want to say is thanks to ACTC for putting on this technology conference, especially Karen and the folks in workforce development. I know they've worked for months on this. Thanks to USDA for some cash to make this happen. Thanks to Chris Boggs and the other faculty here, and Dr. Adkins, the president. They've been great to me over the last several years of my involvement in First Lego League, as well as the other things that are done here on this campus. We're truly blessed to have this kind of a resource in our community. This place is just great. For their forethought and work. It's just cool. That's just a quick bio about me, and let's throw the notes away. Let's say my name is Jim Reneau. I'm a mid-1980s graduate from Ashland Paul Blazer. Was a complete and total lackluster student. Went to Morehead State University. Got a degree in mathematics and computer programming back before there was a computer science degree back there. I absolutely loved it. Let's jump back a little further though. At age 13, I would walk into the Radio Shack, and some of the older folks here might remember this, but they had these computers in the early 1980s called the TRS-80, and it just sat there and blinked and said ready, and there was a blinking cursor, and that's all it did. It just sat there and said ready. And you would type things into it, and it would do things. It would do exactly what you told it to do and do nothing else. It just sat there and said ready. And every time I got near one of these, I would be like, I want to know what this is. And at 13, Ashland Community College, back at the old Ashland campus, had a community and a continuing ed course on how to program a computer. And it was a night course, met 5 nights for a week. And I took that course as a 13-year-old. And I was hooked. I mean, it was like magic. It was like a fish hook in my mouth, and once it set, it never came out. Soon thereafter, I got my first computer, which was the TRS-80 color computer with 4 kilobits of memory. You know that my current laptop has 4 million times the memory of my first computer. The laptop I carry, I have at the farm, is 4 million times the size of memory. It's just amazing to think about where technology has gone just in the few years I've been around. After getting my degree in mathematics and computer programming at Morehead State, I went to work for some consulting firms in Cincinnati and Columbus, where I designed and built business applications. Went self-employed for 15 years, traveling as a consultant, working all over the eastern half of the U.S., doing inventory, transportation, and other computer software applications. In 2004, on a lark, I got my master's at Marshall in computer and information systems, not because anybody paid me to, it was just because I wanted to stay current. And I thought, well, why not? And after completing that, I threw my application in for a job position at Shawnee in 2004, and they said, hey, why don't you come home? And I did. At Shawnee State University, I've had a great career so far. Love it, love teaching, love the students. I've completed a PhD in computer and information systems from Nova, Southeastern University in Fort Lauderdale, Florida. And I'm always looking to learn a new technology, a new field, a new something. A year ago, my wife and I bought 60 acres of rural Greenup County, and I'm now learning silviculture and wild mushrooms. I'm waiting for the morels to pop up, and I'm excited because I want to fry them up in butter and eat them. So I'm always looking for something to do, and I'm always looking for something new and exciting. And thank you for inviting me to come. My talk is about the data architect. You know, IT and computers, everybody talks about the hardware and the networks and the speed and the processors, and yeah, that stuff is sexy. I mean, that stuff is beautiful. The 3D printing is an amazing technology that's going to democratize manufacturing and let us all start building our own stuff, designing our own stuff, and creating our own physical universe. But what about the data behind the universe? That's where I get excited, when I peel the curtain back and look at what's really inside, and look at the information and look at the data. So I'm going to talk about being a data architect. I wish I had my school students here from the local schools, because this presentation was directed to them as much as to all of you, because I'm going to encourage them to go study data and study computer science and study that. I think that you listened to our keynote, and his presentation was wonderful, but I think that there's always going to be a place for somebody who understands the data in business, or at least in our lifetimes and our children's lifetimes. We're still going to need those people. So let's go on into my presentation. Oh, and I didn't include my email address, but I'm jreneau@shawnee.edu. So if anybody wants to contact me, I've got business cards, see me after. I can get you in touch with me. I don't do Facebook or Twitter or Friend Face or anything like that, at least not publicly. So let's. And my presentation is copyright me. If you want to copy the presentation, you can have it as long as you attribute me to creating it. So what is, basically, here's what I'm going to do. I'm going to define a few terms. I'm going to talk about architecture in a generic sense, about people that build buildings and factories and things, real things. I'm going to talk about the similarities between an architect that builds real things and between a data architect. I'm going to talk about the skills that a data architect and a data designer, and I think an analyst and a computer person of the future have to have. I'm going to talk just for a second about jobs. And again, that's why I was hoping I'd have a room full of students, because when they see the numbers, their chins will hit the floor. And questions. So let's, first thing, data is not an android from the 23rd century. For those of you who know Star Trek: The Next Generation. The term data is one of the most important terms that I want to get across. Data is the small facts that a business creates. Data are all the raw numbers that happen every time a transaction, every time an event happens. Think about last time you went to the grocery store. The cashier grabbed that can of green beans and it went beep across the scanner. At that moment, a whole bunch of data was created. What order number it was to, what customer it was for, what loyalty card you scanned, the barcode, the date and time, the cashier number, the store number. I mean, all of that data was created. Think about when they put the bananas on the scanner and type in 4011, hit enter, the weight of the bananas, and several other bits of data were collected. Think about a company like Kroger or Aldi or some other giant company. I don't want to mention their names because I don't like them. Think about all of the data they create. Think of the billions of data points. Think of the billions of raw numbers that they create every day in their business. Think about every time you scan your item at a POS station, or every time a debit card is scanned. The date, the time, the where, the PIN, how long the transaction took, the amount of the transaction, the coordinates of the transaction. Think of a toll collection. Think of every time you swipe a card to go in and out of doors if you're working at a hospital or a healthcare facility. Think of all of the data that a business collects. Think about all of the motions within a warehouse. Think of all of the pieces of equipment. Think of all of those numbers. It becomes so much stuff. There's no humanly possible way to understand that data. There's no humanly possible way to understand it all. I mean, think about how many texts you send a day, or how many telephone calls you make a month, multiplied by 350 million Americans. That's a lot of data. That's a lot of information. So how do we understand this data? Well, we understand this data by distilling it into a product we call information. Information are reports, graphs, charts. If you've studied calculus over the years, information is the first derivative of data. That's kind of the way I like to think of it, is the first derivative of data. Think of information as something that allows a human to understand the data. If the peanut butter buyer at the grocery store chain doesn't need to see every POS scan for every jar of peanut butter that goes through every store, they need to see a report of how many were sold in this region, how many cases were sold in a week in this store, that's the kind of information that person needs. We use the raw data to create that information, but we still needed to distill it to something usable and understandable by the human being on the other end. The next bit of a definition I want is called knowledge. What is knowledge? Well, knowledge is what happens when we as human beings internalize information. From the report, from the graphs, from an understanding of the information, we have knowledge. We know now how to act. It informs our decisions. It makes us better. So we take the data, turn it into information, and then as we internalize the information, it becomes knowledge. So as a data architect and as a business person and as a computer person, your job is not to put the latest whiz-bang desktop and fastest cool 3D technology on every desk. Your job is in the business world and in industry and in governance and in lots of other places, your job is to get the right data into the systems, get it distilled into the right information, and get it into the right minds so that the right decisions can be made. Now maybe in a few years we'll have artificial general intelligence, maybe we'll have systems that will do some of this for us, but will the computer ever really understand, at least in my lifetime, I don't think so, what we as business do? Will it understand the whole entire process? So those are the three definitions I want you to get out of this presentation. If you don't remember anything else, I want you to use the words data, information, and knowledge in corresponding to IT and business computer systems in general, in that term. Use these terms correctly. And I catch myself not, but I really like that. So now we've talked about data and we've defined what data is, because I said we're going to talk about the data architect. Now let's define what an architect is. An architect, and I'm going to talk about an architect that builds buildings, builds factories, builds homes, builds environments. An architect creates environments, places where we live, work, play, create, die, get healthy, all kinds of things that architects build. It's easy to see the results of an architect, and it's easy to even see the fingerprint of an architect. You can look at a building that an architect has done and say, that looks like this other building I know down the street. And probably the same architect did them. It's very interesting looking at their fingerprints. To be able to create a building, an architect needs to really understand his client. Now, because I came from consulting, everybody's a client. Even if it's an employer, I'm still going to call it a client. So where I say client, you can think of that as anybody you're working for, whether it be an employer, whether it be a client in a consulting environment, or somebody you're volunteering for, or anything else. But an architect has to understand the needs of a client. How many square feet? How high ceilings? What type of this? What are their dreams? You know, you don't think about an architect when he's building a building or they're designing a building, she's designing a building, needs to know the dreams of the client. Where are they going to be in 20 years? Or where do they think they're going to be in 20 years? Because it lasts a long time, an expensive building does. What are their likes? You know, some clients want an underground house and don't like windows and don't like light. And others want lots of windows and lots of light. You know, so the architect has to know the wants and likes and future of their clients. Just as a data architect, just as a software designer has to know all of these things too. What are the business's aspirations? Where are they going in the future? We'll get to that. An architect uses a technique called modeling to be able to pull off their job, just as a computer scientist must model to pull off their job. Computers are already too complex for me to comprehend in my head completely. So I have to create simplifications or models to help me understand them. A model would be like a sketch to an architect, where they take a piece of paper and sketch it out and say, how about that? And the client says, no, and the architect can erase and change it and do something else and hand it to them. The great thing about a model is it's really cheap to fix. It's really cheap to change. It doesn't cost anything at all to tweak a model, or very little to tweak a model, where if you had built the building and the client says, no, I want it 3 feet taller, that's going to be expensive, isn't it? So an architect uses models, intentional simplifications, and in your life you're going to have to use them too, especially as a data architect. But a sketch, a blueprint, a scale model, a 3D model. Think about a model airplane. If you went to the hobby store and bought this plastic model airplane and snapped it together, it looks like an airplane. You can gain some understanding about what an airplane does by looking at it, can't you? But it will never fly. Well, unless you fling it at the wall real quick, but it won't last for long once it hits, right? But it still informs knowledge. It still gives us some information as we make our models. So think about the model. Something else an architect has to deal with are limitations. We call these constraints in the computer science and information technology world. Time, money, material. The client wants a pink building. Are we going to build it out of pink marble? Well, that's probably going to be expensive as can be. So that's maybe a constraint that won't work. But could we make it out of, painted steel or plastic? I don't know, maybe. So material is a constraint. Law is a constraint. Zoning laws, handicapped accessibility laws. There are all kinds of laws that go into building a building. And, well, the laws of physics, gravity. Is an important law that an architect has to deal with. And so you can think about an architect has to know the entire person, the entire client, their dreams, their wants, their aspirations, their needs, their future, their plans. They have to know how to model and how to communicate, because that's what a model is, as well as they have to know all of the constraints that exist in the system. A data architect is exactly data plus architect. It almost just kind of makes sense now that I've talked about what data is and what an architect is. A data architect understands the raw data. What are we currently collecting? What data do we have today? Also, what data do we need to collect? Is there data that we're missing? Is there data that we're not collecting, that we should be, or that we ought to be? Of course, we don't want to collect too much data, do we? If we've got a temperature sensor in this room, does ACTC need to collect every second of a reading from this? 60 seconds a minute, 60 minutes a day? Probably not. Would a once a minute or once every 10-minute reading of that temperature sender be enough data? So those are questions we have to ask when we're collecting data. And a data architect has to understand the needs of the business. How does the business operate? What is the business's management's philosophies? What do the owners want out of the business? They have to really understand a lot more than IT. They have to understand a lot more than the computers. They have to understand a lot more than you'd really think they'd have to understand to be able to pull this off. A data architect knows math. I'm sorry, the M word comes out. They have to know, well, we'll talk about the specific math skills that a data architect has to know, but a data architect needs to be a mathematician, needs to think logically. A data architect needs to know accounting, because business and data, that's important to keep track of the beans, right? A business architect, a data architect needs to understand economics. You know, the flow of money and the flow of the economy and the ins and outs of the world. Computers, databases, computer programming, but most importantly, the most important thing a data architect needs to know how to do is to think creatively. Just as the architect that builds buildings has to think creatively, has to come up with creative solutions so that every building isn't just a square, a box with holes. I mean, that'd be really boring if every building looked just alike, right? And to understand a client's needs and to understand the reality of a business, it takes a huge amount of creative thought. A data architect is limited by the same constraints that a real architect, that a building architect is constrained by. Time, money. Now, instead of material, I want to call that data, because some data doesn't exist, some data we haven't collected, but that's a material and it costs money to collect data, right? Laws. A data architect has to deal with laws, and computer scientists have to deal with laws today. There are certain types of information that it's against the law for me to collect. There's certain types of information I don't want, or data I don't want to collect. I don't want to know your social security number. I don't want it in my systems, because if I accidentally let it out, it's a multi-million-dollar claim. I don't want that stuff around. I mean, that's like toxic waste. Right? Credit card information, same kind of thing. Those are things as a data architect we've got to be extremely careful about. Medical information, personally identifiable information, PII, as they like to call it in the medical world. I mean, that stuff is like just nasty. I wish our OLBH guy was still here, because he'd be screaming amen to that about how difficult personally identifiable. And I see your bank shirt. You know, personally identifiable information is scary stuff when you think of the tons of it that you have laying around and what it's really worth and what the liability is. And culture. The culture of the business is important. You know, what does the business do? How do they feel about operating their business? Because feelings go into how the data is analyzed into information. Feelings apply to how that information is internalized into knowledge. So you have to understand the culture of the business. If the owners of the business were in it to maximize profits, you're probably going to look at data differently than if you were looking at a business that's really focused on doing the environmentally and sustainable correct way of doing business. Wouldn't you look at the data two different ways? Completely different ways of looking at the data. A data architect needs specific technologies. You need to know relational databases. Relational databases are the big, giant databases that make business work today. A few of them are SQL Server from Microsoft, Oracle from Oracle, one of the world's largest companies. DB2 is an old database from IBM. MySQL is an open source database that's also owned by Oracle. But these are the databases that drive industry today. These are the databases that I teach in my BUIS 3100 course. These are the databases that we teach to the computer engineering students. They've been around for 20, 30 years. They're the basis behind every major computer application at hospitals and banks and government. Will they be around for a while? Yeah. They're not going anywhere anytime soon. But they're starting to see a transition as we move into the new idea of cloud data. Cloud data, one of the biggest cloud databases is a product called Mongo. And there are other NoSQL or cloud type databases. These are the databases that run Amazon, that run Netflix. Think about Netflix. Think of how much data they have. If you think of every minute of video as a big chunk of data, that's a lot of data. And then they have all of their customers worldwide, and every time you click on an icon, and every time you rate a movie, and every time you make a payment, and wow, Think of the data they have. And then they have royalties to pay back to they actually use a NoSQL, a cloud database, where their movies are actually stored in hundreds of servers globally, scattered all over the world, and pulling in the chunks that you request dynamically. The other thing that you need to know technological to become a data architect and to become the real data driver of your business is you need to know how to code. You need to know how to program a little. You need to know how to program. I don't care what computer programming language you learn, it doesn't matter. Just learn one. The other thing you need to know is the SQL language, which is the relational database language that we use to pull data out of relational databases. You need to know JSON, which is a current technology that stands for JavaScript Object Notation, which is one of the NoSQL technologies, as well as XML, which stands for Extensible Markup Language, which is like creating a web page. For those of you who've ever done HTML, it's very similar, but it's all about data instead of about web pages stored in those kinds of tags. Those are things you absolutely have to know. Those are critical bits of knowledge. You need to understand math, set theory, graph theory, data structures. You need to understand statistics cold. Mean, mode, median, standard deviation, t-tests, Pearson's rho, and all that stuff. You've got to know that. You've got to know that to be able to be a data architect, to be able to communicate the data. You need good communications. You need to be able to make a presentation. You need to be able to create an effective PowerPoint. You need to be able to create reports and specifications. But most importantly, you need to be able to listen and internalize what you hear. You need to be an active listener. If you don't know what active listening is, go Google it real quick. But active listening is the process of where somebody says something and you parrot it back in your own words. So when somebody says something in a meeting, you then say, what I heard you say was blah, blah, blah. And that way they know you get it. That way they know you understand. But you've got to be a very effective communicator to pull off just about anything in today's modern world. And lastly, you need to be able to see the big picture. You need to, again, be creative. And that's hard to do to find someone with math skills and communication skills and creativity skills. I mean, that's really the person that's everything. And to find those people to become your data architects, it's hard to do. But we exist out there. So jobs. According to Monster.com a couple of nights ago, there were over 1,000 jobs that popped up with data architect. I typed data architect, and it said there are over 1,000 jobs. And I opened up the first 5 or 6, and it said mid-career. So we want you to have 5 to 15 years of career experience before you're a data architect. But it's something to hold out there and look at as a potential job. The Bachelor's of Science in Computer Science, Computer Information Systems, and Mathematics was almost always a minimum requirement. Lots of them wanted MBAs on top of that. I'd strongly recommend looking at those. Relational and non-relational data, they wanted a team player, they wanted great communicators, and according to payscale.com, the national median income salary, including salary and stock options and bonuses, was $119,400. That's median. That's the middle. If you're good, sky's the limit. It's a great. And you don't have to get dirty or dig ditches unless you want to. As I said, I recently bought a farm, so I've spent all of my spring break, which ended today, and I'm here instead of out at my farm digging holes and making mud with my tractor. That's so much fun. Everybody needs one of those. So that's what it's all about. I mean, that's my presentation. So I've talked about what is data, what is an architect, and then what is a data architect. It's a smart person who's creative and can communicate and gets technology. You don't have to have the latest whiz-bang laptop, and you don't have to have the fanciest 3D graphics card or 3D printers. It takes a different kind of thought, it takes a different kind of skill. And this is just as important in emerging technology as AI, as drones, as anything else, in my opinion. If you want any more information, come see me. Don't hesitate to contact me, either at the university or here. I'm available for you. And if you know somebody who might be interested, have them email me, contact me. And if they don't come to my school, that's great. I'll encourage them to go anywhere. I'm not one to twist arms for my school. Let's just make the next generation, let's make the next crew that much better.